For this one, we've got a power cycle. It's receiving energy QH by heat transfer from a hot reservoir, which has a temperature of 1200 degrees Rankine. It's going to reject energy, which we're going to call QC, by heat transfer to a cold reservoir, which has a temperature of 400 degrees Rankine. Now, for each of the following cases, we want to determine whether the cycle operates reversibly, irreversibly, or is it just impossible. Now, to get started, I always like to have one of the pictures. So I'm going to go ahead and draw a picture. Up here will be the hot reservoir. So we have that, and this is a power cycle, so we're going to have Q going down into that system. And then down here at the bottom, we've got this cold reservoir. So power cycle QC is going to be discharged to that cold reservoir. Now we need TH, that's 1200. Fortunately, it's already in Rankine. And then down here, TC is 400. That's Rankine also. Power cycle, we're going to have work going out, and that's QH minus QC. All right, now that we got that drawn, let's look at this part A. We're saying that QH is 900 BTU, work of the cycle is 450. So let's check that out, see what it looks like. So let me write these values down. All right, so that's what we were given. Now we know that the efficiency here is going to be the work of the cycle over QH. So let's go ahead and let's plug our numbers in. So we're going to have 450 over 900. Notice the units cancel. That gives you 0.5. So this is saying we have a 50% efficiency. Now to see if this is actually possible and if it's operating reversibly, let's go ahead and check out what the max efficiency should be. Because if we're saying we're greater than the max efficiency, obviously that's not possible. The max efficiency is given by 1 minus TC over TH. Let's plug in our values. So we're going to have 1 minus 400 over 1200. And those are coming from these temperatures here. And the degrees Rankine, those cancel off, so I just left them off. That gives us 0.667. So the max efficiency we could have given these temperatures is going to be about 66% or 66.7%. Ours is less than that, so that means it is possible, and that also means it's going to operate irreversibly. So we'll put eta is less than eta max, so it's irreversibly is the answer. Alright, so now we got that. So basically this is saying we've got some inefficiencies here going on. Part B, we've got a QH of 900 BTU and QC is 300. So let's first look at work. So work's going to be QH minus QC. So that's going to be 900 minus 300. Those are both BTU. So it gives us 600 BTU. Now let's go ahead and find the eta. So that's work of the cycle over QH. So now we're going to have 600 over QH, which was 900. That gives us 0.667 again. Now that value sounds familiar. That's what we got right here for the max, right? So the max efficiency isn't going to change even though our QH and QC are different, right? Max efficiency is dictated by these temperatures of the reservoirs, not our QC and QH. That's QH, by the way. So since this is equal to eta max, then what's that mean? That means it's operating reversibly, because reversibly is the best case that we can have. So you're going to have a reversible power cycle there. Now C, let's look at C. For this one, we're given the work of the cycle, It's 600. QC is given as 400. Now let's see what we want to do here. Again, we're looking to compare it to Eta max. That's what we want to do here. Let's go ahead. We need to get QH to find our efficiency using this equation. So let's go ahead and find QH. We know W is QH minus QC. So with that, we can say QH is equal to W plus QC. So that's going to give us 600 plus 400. And that'll be 1000 BTU. That's our QH value. Now we're just going to plug it in to this equation here. So we'll have work over QH. That'll give us 600 over 1000. That's 0.6. We have a 60% efficiency here. Now this is less than the max value, so this is a possible scenario, and since it's less than Eta max, that means it is irreversible. Okay. And then finally, is Eta 70%? Is that even possible? No. So that's not going to be possible, because this is greater than Eta max. That's impossible because, again, the highest efficiency we can possibly have given these two temperatures of TH and TC is going to be 0.667. So if we're saying 0.7, something's not right there, because you can't have this condition here. So this one will be impossible.